The next point of concurrency that we're going to consider is called an orthocenter. An orthocenter is made by the altitudes that we find in a triangle. Recall that altitude means the height, and so if I were looking for the height of this triangle, I'll situate it this way for a moment. If I were looking for the height of this triangle, considering side CB as the base, the tallest point on the triangle, in that perspective, is vertex A. So I'm looking for the height, and I wouldn't measure from A to just any point on BC. And altitude is really the distance from A, the perpendicular distance, the shortest distance from A to segment BC. So I know I need to draw a perpendicular, and you'll recall that for our review we drew a perpendicular through a point. That's exactly what I need to do. I need to draw a perpendicular to segment BC through point A. So the first thing I'll do is I'll open my compass so that it starts on A and extends past segment BC. And I make that arc, looks like a smile, but it helps me find 2 points that I'll use for reference points when making a perpendicular bisector. And that bisector, if I extend it, will include point A. So once again, I'll make arcs with the same compass opening from each of the 2 new points. And I really don't need to do the below BC arcs because point A is one of the 2 points through which I need to go, and this intersection represents another of the points, and we know that through any 2 points on a plane there's only one line. So I'll go ahead and draw that line. That's a line that includes the altitude. The altitude is really the segment from here to the vertex A. But I'll extend the line so that I have enough information for the next stage of this. Next thing I'll do is I'll turn my paper, my triangle. Now I'm looking at AB, segment AB as the base, and I'm interested in drawing an altitude through C. So the construction stays the same. I need to draw a perpendicular through a point. And you'll see if you open your compass enough that it extends from C in such a way that it touches this segment AB. It might be necessary to extend segment AB, and I'll do that with a dashed line. It's not part of the triangle, but it is an extension of segment AB. So now I'll take my compass again, and I'll put the point of the compass on C and make that smile. And now I have 2 new points, here, and those are the points that I'll use when I'm making my perpendicular bisector, or rather a perpendicular through C. So I have a compass opening that I use from each of my 2 new points, this point and this point. I don't need to do another pair of crossing arcs because I know that through any 2 points there's exactly 1 line. And I can see a place where these first 2 altitudes are crossing one another. I've drawn an altitude, or a line that includes an altitude from A to segment CB, and now I've drawn one from point C to segment AB. So now I have one more, and I'll turn my triangle one more time, and I'd like to draw an altitude that goes through B and is perpendicular to segment AC. I'm going to start by extending segment AC because I suspect I'll need that extension. And I'll extend it with a dashed line because it's not really part of the triangle. And again, I'll open my compass so that it goes past this line, the line that contains segment AC. and I'll make an arc and mark the two places that I'm referencing when I make the perpendicular. So I'm at least halfway from one of those new marks to the other. I think I'll make this arc crossing outside of the triangle. The triangle's getting rather busy. And as I connect those two, I find that it's a little bit off, but it's quite close, that I have the orthocenter. The orthocenter is the point of concurrency that is the crossing of the altitudes of a triangle. The orthocenter, like the centroid, has significance. If I consider point A and point B and point C, together with this new point, I'll call it D, it turns out that if I consider triangle CDB, its orthocenter is A. And if I consider triangle ABD, its orthocenter is C. And if I consider triangle ADB, its orthocenter is B. So for any three, if I pick any three of the 4 points, the fourth of those points is the orthocenter of the triangle made by the first three.